Hello guys, let's prove the standard formula for this integral root x square minus a square dx by using DI method or integration by parts. And I've given guys a similar hint to my previous video on just a square minus x square to kind of not do like this, to not write x square minus a square as x minus a into x plus a, but you can try it if you want, although it will get very lengthy and complex. So you can try it on your own, and if you want to do this in your own way, you can as well. You can pause the video, and I'm going to start right now. And like in the previous or in the both videos, multiply it by 1 and do differentiate DI method plus minus. Since we're trying to integrate to find the integration of this, you have to keep it on the differentiation side, x square minus a square, and integrate 1. Integration of 1 is x, differentiate that. So you have to differentiate x square minus a square to the power of half. Put that power down and then minus 1. So you'll get 1 by 2 x square minus a square to the power minus a half. Now, if you have, let's say, y to the power minus a half, this is just equals to 1 by y to the power half. So this is just 1 by square root of y. So this is just 1 by 2 square root of x square minus a square. But don't forget the chain rule, as you'll have to multiply by the inside of the bracket, the derivative of the inside of the bracket, which is simply 2x, as a square is constant, 2 cancels, and we have this thing. So put that over here. So as in the last two videos, let I is equals to the integration of root x square minus a square dx. Now I and I different, of course. This stands for integration for the DI method. This is just the name holder or the function for this, let's say. So I will be equals to, the first part of the answer is multiplying this and that. Second part is the integration of this row. So we have x root x square minus a square minus the integration of x square by root x square minus a square. Now let's solve this integral right here. So in fact, this minus integration of x square by root x square minus a square dx and x square I'm going to write right here, because if you notice, on the denominator we have x square and also on the top we have x square. Essentially we have the same power of x, but on the bottom we have minus a square. Just don't think about the root for now. So to have minus a square on the numerator, just introduce it, minus a square. But to not change the integral, you have to add it by a square. And now we can just separate the numerator like this. So it becomes minus x square minus a square by root x square minus a square. So essentially you have y by root y, which is just, well, root y. So that means you just have to integrate root x square minus a square dx, and minus plus is also minus. A square is constant, put that outside, and you'll have to integrate dx by root x square minus a square. Now, what is the integration of this? Well, it's that, but we're trying to prove that, so we cannot use it. But this part over here is just our I, so this is just minus I, and this is minus a square. The formula for this type of integral is a log natural of x plus root x square minus a square plus c1. Now let's just put it over here. I is equals to x root x square minus a square. Since we have taken minus this whole thing, so this is just minus I minus a square ln x plus root x square minus a square plus c1. Now let's do some quick maths. This minus I you can put to the left hand side, so it becomes 2I equals to this minus that plus that, and in the next step you just divide by 2, so it's just x by 2 root x square minus a square minus a square by 2 log natural of x plus root x square minus a square plus c1 by 2 will just a constant by a constant, which just gives another constant. Let's just say c, and that is our answer because I is just integration of root x square minus a square dx, and thus we have proven the standard formula. And if you learned something new, please like and subscribe. Thank you.